Just a brief word about me. I'm these days an independent consultant. Folly Consulting is my company. Previously, I've worked for Nortel Networks and also before that various consulting companies. Over the last 5 years, I've been a member of the Internet Architecture Board in the Internet Engineering Task Force, looking at some of the problems of routing and security in the Internet. And over the last 3 years, I've been a member of partner in the Networking for Communications Challenged Communities project, N4C. And N4C is an FP7 STREC project, or was, it's now finished. Basically experimentally driven user-focused research. And the object of the exercise was to look at how we could provide internet-like services in extremely challenged areas, particularly communication challenged areas. The basic technology that we were looking at to help us with this is something called delay and disruption tolerant networking, or DTN as it's known for short. Just as a straw poll, how many of you have ever heard of DTN and know anything about it? Okay, a small proportion. I'll say a little bit more about what it is, since the people who don't know very much about it. So it was a 3-year project, and we've just finished April 2011. And the basis of the work was to formulate 2 test beds, one in Arctic Sweden and one in Slovenia. So there were 12 partners in the project, and the test beds, as you can see, one was right up in the far north of Sweden, up there, and the other was in a small area in Kočeve in Slovenia. The user communities that we were working with in these areas, in Arctic Sweden, it's the Sami, the local population from the past. The economic basis of their existence is reindeer herding. It's still a semi-nomadic culture. They spend quite a lot of time out in the field with the reindeer, which will range over huge areas. It's a huge area of a very environmentally sensitive country. Much of it is a national park. There are indeed extreme challenges in that area, as we found out when we were trying to do our experiments. There is no power, no mains power whatsoever. There's no comms infrastructure. Some of our places we were working were 50 kilometers from the nearest road, 3 days walk or a helicopter trip. The other test bed was slightly less challenged. It's a very sparsely inhabited area of Slovenia. The economic basis there is basically forestry and tourism with some limited farming. And essentially what you're dealing with there is a destroyed culture. It's been the victim of 2 sets of ethnic cleansing in the last 100 years. And as a result, there's hardly any population left, but there are things going on and they want to be able to access the internet. So in a sense, that both the communities that you're looking at there are people who understand what the internet is because they spend part of their time in areas where they can use the internet. But in the core place where they actually spend a lot of their time, they can't access information, they can't access the internet. So we were trying to see whether we could help them in some way. Just as a view of where we're talking about, the large picture there shows some of our target users. And as you can see, it may not be at all obvious, but that is actually a Sami village. There are some inhabitations in that area. So there's actually a tourist cabin, and there's some people living there for part of the year. And in the bottom corner, that is actually a fragment of this picture. It's very difficult to see it on the large picture, but you can see the sort of means we had to do to get the power that we needed to do any sort of experiments in there, solar and wind. So the aims of N4C in sociological terms, we wanted to support the existing cultures that were there. We don't want to destroy them, we want to add to them, we want to work within them. And we wanted to focus on the needs of those communities and design applications and scenarios in conjunction with those local target users. So that was the big aim of the project in terms of the sociological aspects. Obviously, there were technical aspects. We were looking at how to use this delay-tolerant networking to do these things. So why do we need delay-tolerant networking? Well, the conventional internet assumes generally that you have short end-to-end delays in your network, and you get fairly stable connections. And much of the stuff that we use in terms of the protocols and the applications don't really work that well on networks where those requirements are not met. And in the communication challenged regions, as we call them, CCRs, neither of these conditions is satisfied. There are a number of cases where DTN has been used. It came out of something called the interplanetary internet, which Vint Cerf postulated back about 14, 15 years ago. That's obviously a situation where there are very long delays, comms from Earth to space probes. It's unidirectional, but there are scheduled communications opportunities. You've also had a lot of stuff done with what we might call roughly scheduled connections on Earth. Things like the ZebraNet and some of the networks that's been done in Africa. We're using buses and USB keys and such like to transmit data. But the scenario in the middle, which is the one that we've particularly been interested in, was terrestrial, but here with only opportunistic connections in areas where you've got no wired and minimal wireless communications, and the only time you can do data transfer is when you get encounters between nodes according possibly to some statistical mobility pattern. So you're trying to use the nodes when they come together as a way of carrying the data, rather than there being any fixed network that you can use to carry the data around. So we call the DTN a store, carry and forward paradigm. The conventional internet, where you have IP packet forwarding, each individual packet is handled separately. Either you forward it or discard it. You've got pre-calculated routes. We've also got email, somewhat older technology in some ways, where you have unitary transfer of complete emails, but it's basically between static servers. So there's in a sense, no carrying usually. There's a store at the servers, and then it's forwarded as possible. Sometimes it's immediate, sometimes you have to wait around. DTN, in a sense, is a third level that you parcel up the bundle of information, which has got all the information that you need about the message, not just a single packet, but the whole message, just like an email. And you use nodes which act as both to forward it and to carry it around. So it's forwarded between nodes, and then at each intermediate hop node, the information is carried, and it may be mobile, and so the message may move from place to place before it's forwarded again. And the routing mechanisms is used depends on what situation that you're going to be using it in. Sometimes you get static configurations in some cases, schedules, or some mechanisms, delay tolerance, link state, where you know roughly what the shape of the network is. Or the thing that I've been working particularly with is an epidemic mechanism where you send the bundle to as many places as you can think of. Whenever you meet another node, you try and give them the bundle. Sometimes they may be interested, sometimes they're not. And we will talk a little bit at the end of this about what else we can use DTN for besides the sort of things that we've been doing it with the N4C project. So when we're working with the SAMI, we're basically interested in their reindeer movement monitoring and support for their reindeer businesses. Basic applications like email and cached web, and something we call the not-so-instant messenger. They work in families very much, and they're interested in intra-family communication. They use walkie-talkies to some extent, but they're a bit public, and they're a bit competitive. You know, there's competition between the families, and they'd like to keep their information private. And the mechanisms we're talking about give them something to do that. and also environmental monitoring. This is a pretty wild country, and they need to know what's going on as regards weather, so dissemination of weather information and this sort of thing, and weather monitoring is quite important. In Slovenia, the primary aspect of what we were doing was environmental monitoring and some limited support for local businesses. It's mainly communication with workers in remote areas, the forestry workers and such like. And Slovenia is very worried about radiation, even more so after the recent Japanese epic. They have a local nuclear power plant. It's a very small country, smaller than Wales, I think. And they're also people who are worried about the exhaust from some of the local industries, which they think might give them radiation problems. So we were doing both weather monitoring and radiation monitoring. So what are the challenges from this? Well, the terrain and the fact that we're working in national parks. High-frequency radio, which is sort of the only way that you're actually going to be able to do things, is very much line of sight. The terrain is mountainous, so you don't get very far with radios. And it's a sensitive environment, so you're not allowed to install permanent infrastructure. It would destroy it, and anyway, there's no power to use. Power is a big problem. It's sometimes almost more of a problem than communications infrastructure. And one thing which I think is something that we need to think about in this meeting quite a lot is the fact that symmetric communications between things like these mobile phones is not something that works very well today. Something that I came to realise in the process of working on this project, that we really are dominated by a business model which looks at asymmetric communications. We have access points, we have companies, ISPs, that supply us with places to get at the internet. If you actually want to take this mobile phone and somebody else's mobile phone and communicate between them, it'll work for about half an hour before the battery drains. Because the ad hoc Wi-Fi and all the other technologies that are around at the moment just do not work in terms of actually symmetric ad hoc communication. So a lot of the technologies which we talk about and the ways of getting around having no infrastructure are very difficult at the moment, and although it's not made very public, I think there is resistance from the operators to actually going down a path of actually trying to make symmetric communications work. It's not in their business interests because it takes control away from them. So control of the network is currently vested in those who run the access points and the fact that the network is asymmetric. So I think that's a big challenge for us in the future as to how we actually make symmetric communications actually work. So, just as a view of how we transmitted our data about communications in the summer in the Arctic, is either walking or helicopters. And we were transmitting our data in what we call data mules. And that's a picture of one of our data mules, just landing in the lake that you saw in the previous picture. So that's really what N4C has been about actually using, and I think we've been reasonably successful in demonstrating that we can use DTN to extend the internet. The problems that we encountered perhaps are that the users know what the internet is about, and actually trying to extend the internet into these big areas actually made them a bit impatient, to be honest. You know, you could tell them what you were trying to do, but the experiments and actually trying to make these experiments work, they get frustrated because they see what they would like to do and we can't actually deliver at the moment on some of these things. And so there's a level of frustration that we need to solve, and quite quickly in these very challenged areas. And I think we're finding ways of doing that, but it is a matter of finding challenges. The other aspect, which is really outside N4C, but we see that DTN is a way of solving the communications issues in disaster situations and also in the sort of political situations where the infrastructure is cut off. We see that DTN, if you can actually solve this symmetric communications problem, would be a very useful way of being able to transmit information about in a network where, or in an area where the network has died for whatever reason. Either it's because it's been turned off by the authorities, or because it's been destroyed by some natural calamity. So that's where I would like to go with DTN. I'm actually probably going to be involved with SAIL as of sort of immediately now, looking at the information aspects and using the DTN as a way of sending the information around, because obviously if you're carrying the information, you have the information about your person and you can give it to somebody, and provided everybody trusts what you've got, which is a big deal obviously, it's from the point of view of actually knowing that the information that you're getting is kosher. You need to have security aspects from that, solved for that point of view, and of course there's also privacy aspects. So that's a little bit about what N4C is about. Thank you. There's some more information on our websites, and all our deliverables are pretty much there if you want to look. There's a lot of stuff available. Thank you.
Question or two? Yes.
Hi, thank you. That was very interesting. Those of us who traveled down by train this morning and were waving these things around frantically in the air will appreciate other uses of that. One of the things that a couple of very short remarks. One is that I understand that in Korea there's now a government mandate that all future broadband should be symmetric rather than asymmetric, so SDSL rather than ADSL. And
that's a different use of symmetric.
Yes. I understand, but it's symmetric upload as to download.
It's symmetric upload to download.
And
standard,
the question
yes.
this raises is whether we get a different social internet in a world in which it's not content flowing to content users, but it's people communicating one with another. And if you then layer on top of that we no longer assume that people instantaneously receive a message that we send, we may spend more time in thinking through what we send. Mm-hmm. And if we think about how research and science and knowledge progressed in medieval communities, and how, despite the lack of communication, we nonetheless had synchronization because of the complexity of that network of people, it may be that this is rather more than a technology in its own self, but maybe a social technology. And then the final remark is that symmetry also has a role in our backbone structure in terms of peering versus transit arrangements.
Yep.
And that the propagation of these things may change that economic picture as well.
Yes. Yeah, I quite agree. And I think the thing that one has to think about is that there are user cases and thinking about the way in which applications understand the network is important. And the applications have come very much to believe that the network is instant. It ain't. It's perfectly possible to make good the applications, and we found that the users in these areas understood that things were not instant. They were used to dealing with the fact that it took time for something to happen. But you've got to make the applications appropriate, and they've got to understand that they're working in this scenario. And most applications today do not do that. They complain at you because you've got a bad network, and it's your fault, not theirs.
Okay, very good. Thank you so much.